Hey guys, welcome to question MM427 of the Maths Methods Fortify study guide. So in this question we've got Adam who runs a car dealership. He sells all sorts of cars and every car is considered to be part of one of two categories, luxury or everyday. If Adam sells a luxury car, the probability that the next car he sells is also a luxury car is P. If Adam sells an everyday car, the probability that the next car he sells is also an everyday car is P on 3. On any given day, the value of P remains the same for the entire day. The value of P may change from day to day. Awesome. So A says, part A, which is a 3-mark question, says on a particular day, the first car that Adam sells is a luxury car. He knows that the probability of the third car he sells also being a luxury car is 107 on 147. Find the value of P on this particular day where P is less than 0.5. Awesome. So first things first is we need to recognize that we're going to need to draw a tree diagram. Okay. So because we've got this conditional probability going on where we've got dependencies, we need to draw a tree diagram. All right. So the question tells us that on the particular day, the first car that Adam sells is a luxury car. So let's call that L. L. The second car he sells can be a luxury or an everyday. And the third car he sells can be a luxury or an everyday. Awesome. Now, what we're saying is that if he's sold a luxury car on the first day, as the first car, the probability that he sells a luxury as his next car is P, right? The question tells us that, which means that the probability that he sells an everyday car as his next car is 1 minus P, right? Now, if he sells a luxury car, again, the probability that he sells a luxury car again is P, and then this is 1 minus P. If he sells an everyday car, the probability that he sells an everyday car next is P on 3, which means that our probability to sell a luxury is 1 minus P on 3. Awesome. Now, we're looking for the probability. Well, we know that the probability is 107 on 147. And this is the probability that the third car he sells is a luxury car. So the third car he sells, which is that one, and the third car he sells, which is that one. So these two paths are going to multiply together and then add to get to 107 on 147. Okay, so this is actually our first mark, by the way, just drawing this tree diagram. So we know that this probability is given by this path, so P times P, plus this path, so 1 minus P times 1 minus P on 3. Awesome. So then what we get is P squared plus 1 take 4P on 3 plus P squared on 3. And that's equal to 107 on 147. Now, rearranging all this, we get 0 equals P squared, 4P squared on 3, take 4P on 3, plus 40 on 147. Awesome. And then what we get from there is, actually that's our second mark. And then we can chuck this into our CAS because we have our calculator available and say that therefore P is equal to 2 on 7 or 5 on 7. Now, since the question tells us that P is less than 0.5, P equals 2 on 7. And that is our final answer and our third mark for part A. Guys, that's it for that. Let's move on to part B. So part B is telling us that the P value is actually completely changing. So we're going to need to draw a new tree diagram based on our new P value. So we know that P is going to be equal to 3 on 5, right? That's what our question tells us. On a different day, actually, let's get rid of this as well. Awesome. So on a different day, part B I is 2 marks. On a different day, the value of P is known to be 3 on 5. Find the probability that the third car sold is an everyday car, given that the first car sold was also an everyday car. All right, awesome. So first things first is to deal with these probabilities. So if P is 3 on 5, that means that this here is 3 on 5. If P is 3 on 5 here, that means we've got 3 on 5 divided by 3, which is 1 on 5. Awesome. So what we're saying is, given that the first car sold was also an everyday car, so we're saying that the first car sold was an everyday car, second one could be luxury or everyday, third one could be luxury or everyday. Awesome. And what we're saying is that if he sells an everyday car, the probability that he sells another everyday car next is 1 in 5, which means that this has to be 4 in 5 to add to 1. And again here, everyday to everyday is 1 in 5, and this is 4 in 5. If he sells a luxury, the probability that he sells a luxury next is 3 on 5. This is 3 on 5 up here, and this is 2 on 5. Awesome. We're looking for the probability, actually this is the first mark. We're looking for the probability that the third car sold is an everyday car. So we're looking for this path here, so luxury, then everyday, then everyday, then everyday, okay? So we want this ELE path, this one here, plus our EEE path, okay? So this is equal to this path here, so 4 on 5 times 2 in 5, plus 1 in 5 times 1 in 5. That is equal to 8 on 25 plus 1 on 25, which is 9 on 25. And that's our second mark. So guys, this is actually kind of a trick question because it says given that the first car sold was also an everyday car, but we don't actually have to use a given formula. We just need to use that information to start our tree diagram, okay? So it's just the fact that LE and EE, they're the only things that we need to take into consideration here. So there are 2 marks for BI. Let's move on to part BII. So again, BI is a 1 mark question, and again, we're going to have to actually redraw our tree diagram. So I'm going to get rid of that. But our p-value is still 3 on 5, okay? So the question says, find the probability that the second, third, and fourth cars sold are everyday cars, given that the first car sold was a luxury car. Cool, so our first car was a luxury. We're looking for the probability that our second was an everyday, our third was an everyday, and our fourth was an everyday, okay? So this is our second, third, and fourth. So if our first car sold is a luxury, that means that the probability that we sell an everyday the next is 2 in 5, okay? Because the probability that we sell a luxury next is 3 in 5. So luxury down here would be 3 in 5, right? Excuse me. Now, we're looking for the probability that the second, third, and fourth are everyday. So if we've sold an everyday here, then that must mean that the the probability to sell an everyday next is 1 in 5. And same up here. Which means that the probability that we sell a luxury first and then everyday second, third, and fourth is equal to this path. So 2 in 5 times 1 in 5, it's a horrible 5, times 1 in 5. What we get is 2 in 125. And that's our first and only mark for part BI. Yeah, part BII. And that's it. So let's move on to the next one. Right, part BII is actually quite tricky. It's a 2 mark question. We're going to have to get rid of this. BII, 2 mark question. And it says, find the probability that the second car sold is a luxury car, given that the first and third cars sold are everyday cars. Alright, so if our first car sold is an everyday car, then that means that our tree diagram is we're actually going back to our previous BI tree diagram. Okay, so we've got our luxury, everyday, luxury, everyday, luxury, everyday. This is 4 in 5, 1 in 5, 4 in 5, 1 in 5, 3 in 5, 2 in 5. So if you're not too sure how this was created, just check out part BI in this video. The reason we're going back to this is because we're talking about the fact that the first car sold is an everyday car, okay? So that's this diagram here. Now, what we're looking for is the probability that the second car sold was a luxury, given that the third car sold is an everyday. Okay, so third is an everyday. Now, the reason that we don't need to take the first car sold into account with this given formula is because that tells us how to start the tree diagram and what the rest of the probabilities are. Okay, so this probability is equal to the probability that its second luxury intersect third everyday over the probability that it was the third one was an everyday car. Okay, so from here we can say the intersect of the second being a luxury and the third being an everyday is this one, because second is luxury and third is everyday. Okay, so the intersection between those two is those probabilities multiplied together. So 4 and 5 times 2 and 5 over the probability that the third car was an everyday car, and we figured that out to be 9 on 25 in part BI. Okay, so it's 9 on 25. This was actually our first mark here, recognizing that. And then our second mark comes from our final answer, which in this case actually works out to be 8 on 25 over 9 on 25, which equals 8 over 9. And that is our second and final mark for part B, III. Let's move on to part C. Now part C is a 1-mark question and says if Adam's business partner Max also runs a car dealership which sells everyday and luxury cars, but his sales work a little differently. For any given sale, he has a 40% chance to sell a luxury car. Cool. If Max makes 6 sales in a day, what is the probability that exactly 4 of the cars sold are classified as luxury cars? Give your answer correct to 4 decimal places. Awesome. So because this is a 1-mark question, we can actually just do all of this in our CAS and write the answer down. So the thing we have to recognize here is that we're not dealing with conditional probability anymore, right? We're dealing with binomial probability because he has a certain percentage chance to sell a luxury car regardless of what he's sold before. So these are completely independent trials, and each trial has the same probability to sell a luxury car, okay? So what that means is we pull out our binomial CDF. It's going to ask us for our lower, upper, N, and P. And so we're looking for the probability that exactly 4 of the cars sold are classified as luxury cars. So we know that the X value that we're looking for is 4. We're not looking for a range of values, so our lower is 4 and our upper is 4 as well. Now you could also use binomial PDF and just say the X value is 4, but I just use CDF in this context as well. So our N value is how many sales he's made, so our number of trials, which in this case is 6, and our P value is the chance that he sells a luxury car, which is 0.4. Now plugging this into your CAS, you find that probably the X equals 4 is equal to 0.1382. This is our first and only mark for part C, guys. That actually wraps up MM427. So if you have any questions about any of this question or solution or whatever, please hit me up in the comments below. But otherwise, as always, guys, thank you for watching, and I'll see you in the next video.